The action potential is a fundamental electrical signal in neurons, acting as the means by which they communicate. Picture a small, resting neuron poised to respond to a stimulus. Its membrane is polarized, and the inside has a negative charge compared to the outside. This resting state is essential, resembling a tightly coiled spring ready to unleash its energy upon activation. As the neuron encounters a stimulus, it reaches a threshold level that triggers the rapid changes characteristic of an action potential. Upon reaching this threshold, sodium channels in the neuronal membrane open, allowing sodium ions to flood into the cell. Visualize this as a sudden burst of light piercing through darkness as the interior of the neuron transitions from negative to positive. This depolarization phase happens swiftly, characterized by a spike in voltage that travels along the axon. The rapid influx of sodium creates an electrical wave, setting the stage for the signal to cascade down the neuron. Following the depolarization, the sodium channels close and potassium channels open. This is akin to a dam being released, allowing potassium ions to exit the cell, restoring the negative internal environment. This phase, called repolarization, is rapid yet temporary as the neuron works diligently to re-establish its resting potential. This process provides a visual metaphor for the ebb and flow of an ocean tide, moving swiftly but inevitably back to a calm state. After the action potential passes, there is a short period of hyperpolarization wherein the membrane potential drops below the resting level. This moment acts as a safeguard, ensuring the neuron does not fire again immediately, a crucial mechanism to prevent confusion in the transmission of signals. In this state, the neuron is momentarily incapacitated, needing time to reset before it can fire again, resembling a sprinter catching their breath after a sprint. Understanding action potentials is vital for grasping how neurons transmit information across the nervous system. Each signal travels along the axon with remarkable speed, enabling coordination of bodily functions and responses to stimuli. The perfect orchestration of depolarization and repolarization illustrates the beauty of biological communication, highlighting the astonishing complexity of neuronal behavior that underlies all thoughts, movements, and sensations.